Patterns and scatter plots. Open your book to page 38. Start the warm-up with Mrs. McDonald. All right, patterns and scatter plots. A scatter plot is data points that are scattered and don't quite make a line. Like in this case of this first scatter plot, this is a linear scatter plot that almost forms a positive line. So this one has a positive correlation. Or in other words, it would have a positive slope. In the case of the second graph, this would have a negative correlation or a negative slope. In the case of the third graph, the points are scattered all over the place and there would be no correlation. Throughout the next several lessons as we look at scatter plots, we're going to be looking for the ones that look like they form close to a straight line, and we'll be looking specifically for their equations. Oops. Okay, in the next several exercises, we're going to look at the scatter plots, and we're going to answer 3 questions for each plot. Okay, so for this first one, it says, is there a relationship? If there is a relationship, does it appear to be linear? And if the relationship appears to be linear, is it positive or negative? So in the case of the first one, is a relationship? Yes. Is the relationship linear? I would say yes. And does it appear to be negative or positive? And I would say that it is negative. Okay, the points go negative means that the points go, when you look at it from left to right, the points are going down. Okay, next scatter plot. Is there a relationship? Yes. You'll know and know when we get to one. That would be the one that's scattered all over the place. Does it appear to be linear? The answer would be yes. You'll know when that's not linear when we get to one. And does it appear to be positive or negative? And this would be one that's positive. Positive means that the points go from, looking at it from left to right, points are going upward. Okay, number 3. Is there a relationship? Let's see, I would say this one is this one's a little hard to tell. Is there a relationship? No. So if there's not a relationship, we won't be able to answer this question. And we won't be able to answer this question. Okay, on this one, now this one here where I said no, the points were pretty scattered. But in this case, there is a relationship. This one's yes. But it's not a linear relationship. This one's a no. I don't know if you guys talked about this last year. I think you did. But in this case, this one looks like there's a curve in it. Like if you follow this, it looks like maybe there's some kind of a curve in the graph, which is a relationship. It's just not a linear relationship. Linear means line. And since it's not linear, then we cannot answer this question. And that's why it took me a few minutes to look at this one to see if there was a relationship or not. I'm still saying no on that one. Okay, 5 is very obvious. That's not a relationship. Which means I cannot answer this question, and I cannot answer this question. Okay. Below is a scatter plot of data on weights in pounds x. So that down here on the x-axis, these are weights in pounds, and fuel efficiency in miles per gallon for the y-axis. That's the fuel efficiency for 13 cars. Using the questions at the beginning of the lesson as a guide, write a few sentences describing any possible relationships between x and y. So let's see, does this look like it has a relationship? I would say yes. Does it look like it's a linear relationship? I would say yes. Does it look positive or negative? It looks like it's a negative relationship. So as far as this few sentences go, it looks like this. There is a negative linear relationship between the fuel efficiency let's see, what that means is that, let's see, I said write a few sentences. What that means is as the car's weight increases, fuel efficiency goes down. Okay, number 7, it says below is a scatter plot of data on price in dollars and quality ratings of 14 bike helmets. Using the questions in the beginning of the lesson as a guide, write a few sentences describing any possible relationship between x and y. So for this one, does it look like there's a relationship between price in dollars and quality ratings? This one's looking pretty scattered to me. So I would say let's see. The price of, let's see, what was this? The price of bike helmets doesn't appear to have a relationship with the quality rating of the helmet. Now I would think there would be, but based on those 14, it doesn't really look like it. Okay, here's the next one. It says below is a scatter plot of data on shell length in millimeters and age for 27 lobsters of a known age. Using the questions at the beginning of the lesson as a guide, write a few sentences describing a possible relationship between X and Y. So it looks like as the shell lengths get bigger, the age is getting bigger, but this one does not look like it has a linear relationship. It looks more like a curve. So what was this? The shell length of what? Oh, lobsters. Let's see, I'm going to start over. Hang on. So I'm going to start off with, first of all, it's a positive relationship. So it looks like there's a positive relationship between a lobster's age and shell length. As the lobster gets older, oh my goodness, no apostrophe on gets. It's not tail, shell. There's a couple sentences. Its shell length increases. Okay, last one, I think, maybe? Yep. Below is a scatter plot of data from crocodiles on body mass, that's how big they are, and bite force. Using the questions at the beginning of the lesson as a guide, write a few sentences describing a possible relationship. Now this one not only looks positive, it looks linear. Okay, so it looks like the body mass and the bite force has a positive linear relationship. what was this again? Body mass and bite force of a crocodile. As the crocodile grows in size, its bite force gets stronger. And that's the idea of today's lesson.